Muller's method. Muller's method was first presented by David E. Muller in 1952. David Eugene Muller was born in November 2, 1924 in Austin, Texas, and died on April 27, 2008. He is the son of Herman J. Muller, a Nobel Prize awardee in 1946 for his discovery of X-ray-induced mutations in Drosophila melanogaster, and Jess Jacobs Muller, a mathematician. Muller was an American mathematician and computer scientist who worked as a professor in mathematics and computer science at the University of Illinois in 1953 to 1992. He then became an adjunct professor of mathematics at the New Mexico State University in 1995 to 2008. He published more than 50 research articles, one of which became known as Muller's method. Muller's method starts with three initial approximations to the root: x sub 0, x sub 1, and x sub 2. Through these points, we have the function of x sub 0, the function of x sub 1, and the function of x sub 2. From these three functions, we now have our new parabola, that is p of x equal to a quantity x minus x sub 2 squared plus b quantity x minus x sub 2 plus c. Using the quadratic formula in Newton's form, p of x equal to f of x sub 2 plus b quantity x minus x sub 2 plus a quantity x minus x sub 2 multiplied to x minus x sub 1. Computing for a and b by Newton's divided difference polynomial, we have a equal to quantity f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1 subtracted to f of x sub 1 minus f of x sub 0 all over x sub 1 minus x sub 2 minus 1 over quantity x sub 2 minus x sub 1 plus quantity x sub 1 minus x sub 0. b equal to the value computed from a multiplied to x sub 2 minus x sub 1 plus f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. Equation of x sub 3, we have x minus x sub 2 equal to negative b positive negative square root of b squared minus 4ac all over 2a. We multiply this by negative b negative positive square root of b squared minus 4ac over negative b negative positive square root of b squared minus 4ac. That would be equal to negative b positive negative square root of b squared minus 4ac multiplied to negative b negative positive square root of b squared minus 4ac all over 2a multiplied to negative b negative positive square root of b squared minus 4ac. Using completing the square, we have b squared minus square root of b squared minus 4ac squared all over 2a multiplied to negative b negative positive square root of b squared minus 4ac. Cancelling the square root and the square, that will leave us with b squared minus b squared minus 4ac over 2a quantity negative b negative positive square root of b squared minus 4ac. Distributing the negative sign, we get b squared minus b squared plus 4ac over 2a quantity negative b negative positive square root of b squared minus 4ac. b squared minus b squared, that will be 0, and 4a divided by 2a is 2. We now have 2c over negative b negative positive square root of b squared minus 4ac. Transposing x sub 2, our equation will now be x sub 3 equal to x sub 2 minus 2c all over b square root of b squared minus 4ac.
Hi guys, my name is Marian C. Kaimo from BSE 4A. This video is about root finding using Muller's method. This method was first presented by David E. Muller in 1956. Okay guys, this is David E. Muller. This technique can be used for any root finding program, but it is particularly useful for approximating the roots of polynomials. Muller's method is an extension of the second method. Here is our graph with the parabola, and we will assume 3 points, which are x sub 0, x sub 1, and x sub 2. This method is good at finding complex roots. Let's start with initial guesses, x sub 0, x sub 1, and x sub 2. Then get the value of f of x sub 0, f of x sub 1, and f of x sub 2. Here are the formulas we are going to use. H sub O equals x sub 1 minus x sub O. H sub 1 equals x sub 2 minus x sub 1. Delta sub O equals f of x sub 1 minus f of x sub 0 all over x sub 1 minus x sub O. Delta sub 1 equals f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. A equals delta sub 1 minus delta sub O all over h sub 1 plus h sub O. B equals a times h sub 1 plus delta sub 1. C equals f of x sub 2. X sub 3 equals x sub 2 plus negative 2c all over b plus or minus square root of b squared minus 4ac. And last, the value of percentage of error is equals to absolute value of previous value minus present value all over present value times 100%. Guys, x sub 2 stands for previous value and x sub 3 is our present value. An example, f of x equals x cubed minus 13x minus 12, and the three initial guesses be x sub O equals 4.5, x sub 1 equals 5.5, and x sub 2 equals 5. Now, to get the value of x sub O, f of x sub O, we're going to substitute the value f of x sub O to our equation. 4.5 raised to the third power minus 13 times 4.5 minus 12. We will have 20.625. F of x sub 1 equals 5.5 raised to third power minus 13. 5.5 minus 12 will give us 82.875, and for the last, f of x sub 2 equals 5 to the third power minus 13 times 5 minus 12 will give us 48. Now we're going to solve for a sub O using the formula x sub 1 minus x sub O. That will give us 5.5 minus 4.5 And the answer will be 1. And h sub 1, using the formula x sub 2 minus x sub 1, it will give us 5 minus 5.5. Answer is negative 0.5. Now we're gonna find the value of delta sub O using the formula f of x sub 1 minus f of x sub 0 all over x sub O. It will give us f of x sub 1 82.875 minus 20.625 all over 1. The answer will be 62.25. That's the value of delta sub O. And the value of delta sub 1 using the formula f of x sub 2 minus f of x sub 1 all over h sub 1 will give us f 48. 48 minus 82.875 all over negative 0.5. The answer will be 69.75. The value of A, let's use the formula delta sub 1 minus delta sub O all over h sub 1 plus h sub O. It will give us 69.75 minus 62.25 all over negative 0.5 plus 1. The answer will be 15. Now for letter B, A times h sub 1 plus delta 1. It will give us 15 times negative 0.5 plus 69.75. The answer will be 62.25. And since C is equal to f of x sub 2, we already have C 48. For x sub 3, we use the formula x sub 2 plus negative 2c all over b plus or minus square root of b squared minus 4ac. It will give us 5 plus negative 248 all over 62.25 plus or minus square root of 62.25 squared minus 4 times 15 times 48. That will give us 4.335. So, dito kasi sa Muller's method, kadalasan ginagamit plus lang. So, eto na yung sagot. Now, we're going to solve for the value of percentage of error using the formula absolute value of previous value minus previous value is our x sub 2 minus x sub 3. And the present value x sub 3 times 100%, which give us 5 minus 4.335 all over 4.3 4.35 times 100%. The answer is 15.3403. And that's our percentage of error. After you get the value of percentage of error, the three initial guesses will be replaced. So now the new three initial guesses will be x of 0 equals 5.5, x of 1 equals 5, and x of 2 equals 4.335. Kung mapapansin nyo guys, yung kaninang nakuha natin na x of 3, yun yung naging bago nating x of 2. So, repeat the process, the procedure, until you reach the zero value of error, percentage of error. So, guys, kung mapapansin nyo, red yung ginamit ko kasi naubusan ako ng black ink. Sana naintindihan nyo.